Hello and welcome to Sparks Precalculus. We are on day number 9. We're going to talk about discontinuities in the graphs of piecewise defined functions, and we're going to talk about two specific types. We have what is called point discontinuity, which means two pieces that connect in an open circle. And the other type of discontinuity we're going to talk about is jump, which is two pieces that do not connect. So go ahead and graph this piecewise function, f of x, and check your graph with me before we go ahead and answer the questions about it. So pause it right now. So this is what that graph looks like. Let's talk about the domain. So we talk about domain, we're starting with the very smallest x value, which from that arrow we can see, and from here, there's no end point to the left, so all reals to the left. So we're going to start with negative infinity, and then when we get to that -2, right here where I broke it, it's an open circle, so it's open, and then we have -2 to positive infinity. And then for our range, notice that that circle is maybe not filled in right there, but it gets filled in by this part of the graph over here. So that is included in our range. So it's negative infinity to positive infinity. So let's talk about the more interesting piece of the graph is where these two pieces come together. So when x is equal to -2, if we're starting for the first piece, which would be that function, we could plug -2 in to see what would happen if it existed there. So we could say a -2 plus 5 inside that absolute value bar plus 7, and we'd get out +4. If we looked at it from the second piece and plugged -2 in here if it existed, we'd get 1/2 times -2 plus 5, and we also get out 4. So our conclusion about f of x at x equals -2, because they're both going to the same value, then we can say that f of x has a point discontinuity at x equals -2. Mathematically, we could talk about what happens from the left and the right. We would say as x goes to -2 from the left, the graph of f of x goes to +4. We're going to use that arrow to mean goes to. As x goes to -2 from the right, the graph of f of x also goes to 4. Since the graph of f of x goes to the same y value from the left and the right, f of x is not equal to f of -2 when x equals -2, then f of x has a point discontinuity at x equals -2. Alright, so now you try that. You're going to graph it, you're going to do the domain and range, answer all the questions, and complete the following statements. So if you want, I'm going to graph it. So you pause this, I'll graph it, you graph it, and then turn it on and check make sure your graph is right. Because if your graph is not right, then all the questions you answer about it may not be right. So pause it and then graph it. Alright, so double check that you got this graphed correctly. And then now pause this so you can answer these questions and check your answer. Alright, so domain and range, both are all reals. Notice this notation that I'm using right here. This will continue to go with us as x approaches or goes to -3, and this negative means from the left, which is the negative side. Then we got -5. Actually, that should be +5. Sorry about that. This one says as x goes to or approaches -3, and it has a little positive sign right there. That means from the positive side, which is from the right. you end up with -1. And then a conclusion, since they're not going to the same place, it has a jump discontinuity. So as x goes to -3 from the left, it's equal to 5. As g of x goes to the right, the graph is going to 1. Since graph of g of x is going to a different y value from the left and the right when x is equal to -3, then g of x has a jump discontinuity at x equals -3. So let's go ahead and put this in words. A point discontinuity, two pieces approaching the same y value. And if we're talking about at C, x equals C, and also f of C doesn't have to be defined. It wasn't defined in our example. Oh, on the other page, it wasn't defined because there was nothing, these were two open circles in our first example. F of C doesn't have to be defined, but it certainly could be defined. Jump discontinuity, two pieces approaching different y values. And again, at C, at x equals C. It should look like this one, sorry. And again, f of C may or may not be defined. The next two pages, I'm going to go ahead and scan in, and will be a downloadable file so that you could take a look at what the rest of those should be. But I'm going to let you try those on your own, and then you can check your answers. All right, until next time.